Let's talk about something you use dozens, maybe even hundreds of times a day, and you probably don't even think about it. It's this invisible engine that's running pretty much our entire modern world. So what is it? Well, we're talking about databases. Seriously, just stop and think for a second. How many databases have you already interacted with just today? I'm willing to bet the answer is way, way higher than you think. Let me show you what I mean. Did you check your bank account on your phone? You know, in that split second you tap the screen, your app fired off a super secure request to your bank's database. It had to pull your specific info, your name, your balance, your latest transactions, out of this massive, heavily protected collection of data.
And it's not just about money. You've probably scrolled through some social media today, right? Well, every single profile, every post, every photo, every like, it all lives inside a database of almost unimaginable size. Your simple thumb scroll is sending this constant stream of requests, telling that database to instantly serve up the latest stuff from your friends.
Or, hey, maybe you bought something online. That's another huge one. E-commerce giants are juggling these enormous databases with millions of users, countless products, and just a flood of new orders coming in every single second, all tracked with incredible precision.
What about booking a flight? Airlines were actually some of the very first pioneers to use databases on a massive scale. They kind of had to, for all their reservations and scheduling. Every single seat on every flight is just one little piece of data in an incredibly complex system.
Okay, so we get it. Databases are everywhere. But to really appreciate why they're such a game changer, we've got to rewind the clock a bit. We need to understand the problem they were invented to solve. The old, unbelievably messy way we used to handle information.
So picture a university back in the day. The grade office has its own file on students with their names and grades. Meanwhile, across campus, the accounting office has a completely separate file with student names and their payment info. Now, what happens when a student moves? They tell the grade office their new address, but they forget to tell accounting. All of a sudden, the university has two different conflicting addresses for the exact same person. That's data inconsistency, and it was a gigantic headache. And that little university story really gets to the heart of the difference. The old way, that traditional file processing, it was pure chaos. You had data scattered all over the place, duplicated, inconsistent. But the database approach, it brings order. It centralizes everything. It creates one single source of truth, gets rid of all that messy duplication, and, this is a big one, it separates the data itself from the programs that use it.
So how does this smarter system actually pull this off? What are the building blocks that create all this order out of the chaos? Well, it really just comes down to three key concepts. First, you have the most basic ingredient of all: data. Just think of data as the raw facts: a name, a price, a date. It's the raw material for everything. But, a random pile of facts isn't very helpful. That's where the database itself comes in. It's not a junk drawer of information. It's a logically organized collection of related data, all designed to model something from the real world, like our university.
And finally, we get to the most important piece of the puzzle, the Database Management System, or DBMS for short. Now, if the database is the library full of books, the DBMS is the genius librarian. It's the software that lets us build the library, keep it organized, and find any piece of information we need, like instantly.
Honestly, the DBMS is the real unsung hero of this whole story. So let's give it some credit. We can think of it like a data superhero, with a set of core powers that bring safety and order to our digital lives.
So this superhero has four main powers. First up is defining. That's the power to set all the rules for the data, like what it's supposed to look like and what's allowed in. Then you've got constructing, the power to actually build the structure and store all that data safely. The third power, and the one we use all the time, is manipulating. That's asking questions, updating info, getting reports, and finally, the really crucial power of sharing, which lets lots of people use the data at the exact same time without causing a total meltdown. And here's where it all clicks into place. These powers directly solve those real-world problems we talked about. They control that messy redundancy, they keep data secure, they provide backups, but this concurrent access power is especially cool.
Let's go back to that airline example. When thousands of people are all trying to book a flight online at the same moment, the DBMS is the thing that prevents two people from booking the exact same seat at the exact same millisecond. It has this special software that basically makes everyone take turns in a super fast, orderly way, so the data never ever gets corrupted. It's amazing, really.
Of course, it's not all just software. There are real people involved here too. You have the database administrator, or DBA, who's like the guardian of the system, managing the whole thing and deciding who gets access.
Then there's the database designer. They're the architect, figuring out the smartest way to structure all the data. And then, well, there's us, the end users, the customers who are using the database every single day.
All right, so we've seen the old way and the new way. Let's just zoom out one last time and tackle the biggest question of all. Why does any of this really matter? Well, it all boils down to one fundamental shift. We move from absolute chaos to predictable, reliable order.
The most crucial point is this, right here. The database approach creates a single, central place for data to live. You define it one time, in one place, and then everyone, no matter what department or what application they're using, accesses that same single source of truth.
And maybe the biggest superpower of the whole system is something called program data independence. See, in the old world, if you changed one tiny thing about a data file, you literally had to rewrite every single program that used it. It was a complete nightmare. But with a DBMS, the data and the programs are separate. You can update the database and the apps just keep working. That single idea saves an unbelievable amount of time and effort.
Ultimately, what this independence gives us is massive flexibility. It cuts down development time for new apps, and, most importantly, it guarantees that everybody is working with the exact same up-to-date information. No more conflicting addresses, no more inconsistent records.
So, the next time you check your bank account or book a plane ticket, just take a second to remember the database management system. It's that unsung hero working silently in the background, bringing structure, security, and incredible efficiency to almost every single thing we do online.
And that leaves us with one final thought to chew on. Right now, we are creating more data than at any other point in human history. It's like a fire hose that's always on. So the big question for the future is, what new problems of massive scale, incredible speed, and even intelligence will the next generation of these invisible engines need to solve?